Okay. Hello, everyone. I'm Asparuh Koev from Transmetrics, and last year Transmetrics won the Future Cloud Challenge in Berlin, which came at a really critical point in our 18 months life as a startup where we needed a bit of confidence boost. So thank you very much, ICT Labs, for that. ICT Labs asked me basically to talk about Transmetrics, but also cover on the entrepreneurial journey. So where did the idea come from, the technology as enabler, the main steps in the journey, the success factors, and difficulties and surprises and advice I could give to people starting down that road. So my entrepreneurial journey started actually earlier than Transmetrics. It was in 1995 in Bulgaria. At that time, Bulgaria was making the transition to democracy. The picture you see is 1 million people demonstrating in Sofia. Luckily, that time is now over. Back then, the salary in Bulgaria was $20 per month, which gave us an enormous advantage in terms of if we could produce something which could be attractive to the West, basically we could have an enormous cost advantage. So we started a software company of 5 people in a university lab, which grew to 350 people and then got acquired by VMware. And now it's called VMware Bulgaria, and it's in this nice building downtown. My next step in the journey was starting a consulting company in 2003. Which by starting by myself, I grew to 10 people by 2008, and we had 3 customers at that time, and the customers' names were DHL Express, DHL Freight, and DHL Danzas Air and Ocean. You can see where the problem is there, actually. And at that time, everyone was telling me, you have spent 5 years working for DHL, you will always be a DHL company. So fast forward 4 years later, basically, we still had 3 divisions of DHL as customers, but we also had all these other guys, some of which are well-known names in transport. And I suppose the lesson of the story is basically there will be always people who will tell you this is going to fail. And I mean, sometimes it just needs time. And then by the end, we were just doing projects in Russia and so on. And that's where I stumbled into the idea of Transmetrics. And Transmetrics is bringing big data to cargo transport to improve capacity utilization. And how did that happen? I was sitting at a conference, the TOC. It's a very big transport conference in early 2012. It was a long session, and I had just met several customers who had basically the same request that I couldn't do anything about being a consultant. So I spent a bit of time thinking about it, and this is the page where the idea of Transmetrics was drafted back then. So I suppose the lesson learned here is go to conferences. They're a great source of inspiration, but also always bring your notebook with you because you don't know what is going to happen. And another thing which is interesting here is it's too small to see, but in the lower corner, basically there is a section called potential customers. Basically the first one on the list is DHL Express Aviation. And it's very important to really think about if you want to do something, who is going to buy it, and not in the abstract, large corporations, large transport companies, but have a very specific idea about who is going to be the first customer and how is it going to work. I'll come back to that point later on. And then, because startups need to be separate, it's a very big mistake which I've made personally of trying to run a startup inside a larger company. And it's very difficult because you have all these big customers who are paying you a lot of money to do stuff for them, and then you have to do this small tiny thing which is not going to produce revenue for 18 to 24 months. And it's very difficult to convince your colleagues that it's worthwhile to be spending your time on that. That's why I left the consulting business and started Transmetrics as a startup. So a bit about Transmetrics. The cargo transport industry is 2 trillion euros, and half of that amount is spent transporting just empty space. It's very inefficient. And in addition to the staggering cost, it also has fuel burning and carbon emissions implications. A lot of the empty space is there because the cargo volumes for a transporting company fluctuate a lot from day to day. One day there is a lot to ship, the next day very little, and because of that they end up half empty on average. However, these changes are not random. They depend on a large number of external factors such as weather, public holidays, and the like. And if you can take this into account, then future volumes become more and more predictable the more factors you take on. The impact can be staggering. In our laboratory tests, we've shown 47% to 18% empty space and 3 times more profit. And that's why we are building the product now. It's close to having a demo, where transport companies can load their shipping history correlated with external signals such as weather and public holidays in order to build to understand where the empty space is going to be 6 weeks ahead, so they can take mitigating actions on it. Our current research partner customers is DHL Express Aviation. I mentioned that before. Basically, I didn't know whether they were going to take it or not, but they took it, and that really put us on another level. Agility Logistics, which is a pretty large company, about 4 billion euros, and European Containers, a 200 million company from Northern Europe. And their research, I'm calling them research partner customers because they haven't given us any money, but they have given us something far more valuable, their data. In the case of DHL Express, this is about 5 to 6 terabytes of transactional data, which basically allows us to build a very good product. The team, basically, we have 4 co-founders, 2 on the business side, myself and Anna, and 2 on the technical side, Radu, who is into mathematics and prediction, and Alex, who is into big data. We have 8 more people. 2 are interns, are being replaced by 2 permanent people after the summer. So, and that's where we'll be for the next, I would say, 6 to 9 months as we are building the product. We have a very strong advisory board coming from the industry. That's another lesson learned. Actually, if you want to run a startup, actually advisors are much more important than investors. They're probably second most important to the team and customers only. Having active advisors allows you to do a lot of things, open a lot of doors. Our plan at the moment is to have a demo version basically by September, so that we can start sales and get first contracts, and then we can release meanwhile the full version of the product and start getting an early revenue so that we can get the next investment round, which is, as a startup, the way to survive in a way, continue getting funded. So some lessons learned on this journey. The first thing is I cannot emphasize how much it helped that I knew the space, basically. These are just some of the companies who really easily opened their doors, and I could go and talk to the relevant people there just because I've been a consultant in the industry for 10 years and I knew people and they knew people that they could introduce me to. And it's a great advantage to be starting a startup in a space that you know very well. And if I had been doing it in banking, for example, or healthcare, probably it would have failed because I couldn't talk to the right people. This also allowed us to iterate the idea several times because just to illustrate how the idea works. How the idea worked, basically, we started with the concept that we'll be reducing empty space by better long-term network design. That was my hypothesis back at the transport conference. And okay, we went to 10 companies. We realized that reduce empty space is a worthwhile goal, and they're willing to spend a lot of money on it. But actually, they didn't see the network design as being the core issue. And where they were thinking about network design, it was more like, if I open a new terminal, am I going to be able to find the right customers for that terminal? And this is not where we could help, really. So that part failed, but still we had something which was right. And then we went on the next iteration. So reduce empty space by short-term action, fine-tuning the network to match the given demand. So once you know what is the demand for shipping, you basically do corrective actions on the network and you reduce the empty space. Great. We talked to customers. Yes, the short-term action resonated. They felt that this is where they're not doing enough, basically in the next 2 to 6 weeks. However, there was a very big issue with this fine-tuning, and that was that we set a given demand, but demand is not given, or actually it is known only at the very last moment. If you give a shipment to DHL today, it will be on the plane this evening, but yesterday they didn't know that you were going to give them a shipment. So that fine-tuning thing failed, and then we said, okay, we'll reduce the empty space by short-term action using big data prediction to trigger sales action. So you predict where the empty space is going to be, and then you sell it in advance at a discount. That one already worked. So we found a class of customers where basically this is the right approach. Use big data prediction to trigger sales action, mainly the large companies. But then we discovered other scenarios. Other companies could use the big data prediction to manage empty containers, for example. Empty container logistics is a very big problem. And other customers can use it to trigger supplier contracting. For example, I'm going to order 5 trucks additionally, basically tomorrow, because I know I'll have more demand. And I suppose the moral of the story here is that it's important to be able to evolve your idea and drop the parts which don't work and collect piece by piece the parts which do work, and that will eventually take you to a place where you have really an innovative idea which well fits the world as it is. And the next thing is we started doing prediction, and our first vision on the prediction was something like this. There's going to be a very smart computer which is going to figure out everything by itself. There are neural networks, there are all kinds of sophisticated algorithms, and it will be all automated. I'm even embarrassed about the slide I'm going to show you, but when we started with DHL, I showed them this slide. Okay, in terms of prediction, we are looking for the needle in the haystack, but we are going to use the computer as a very powerful magnet to pull out all the needles and sort out everything, basically. And unfortunately, it completely didn't work out that way. It turned out that all the powerful algorithms which exist require that you know exactly what you're looking for, and then you can calibrate them to work. But if you just try to throw them out of the box, you get nothing, basically. And that brought us back to the drawing board, and we started to basically do business modeling of the data, manual analysis, and so on. And we found things which work, and we started to put them into models. And now we are on the right track, but we also lost, I think, at least 3 months. By this incorrect hypothesis. The other thing which turned out is that actually there is a lot of powerful instruments, again, basically, especially in finance, Garch, RIMA, hidden Markov models, neural networks, and there are another 10 that I can list easily. And basically all these ones were initially defeated by a very simple algorithm, which is take the median of the last 6 weeks. So the middle value which happened among the last 6 weeks. And basically it actually produces, without a lot of calibration, much better results than all of these complicated models, which is very disappointing, especially because the median you can do in Excel. And it's not that much data, so there was a point where I was feeling, okay, no one needs this solution, basically. And of course, the point is that it's very, very difficult to defeat a very simple model, but it is possible to defeat it by a very complex and very well-calibrated model. But it takes a lot of time. But anyway, if you start immediately with the large models, you might be feeling that you're doing something and making a progress, but actually if you haven't beaten the small guy yet, basically you haven't done anything. And especially disconcerting is that your customer normally knows, at least intuitively about the small guy. So you have to be aware of this simple solution, I guess. Now, the next thing which was really interesting was the data sources. We had this feeling that, oh, there is a lot of data everywhere. The weather is there, all the flights are there, everything is there. Basically, we just have to pull it. It turned out that, first of all, the data quality is not there. Basically, a lot of the big data is massively wrong because it has been collected by processes that you don't understand, and then adapted by people who adapted it for their own purposes versus your purpose, and then what can you do with it, basically? Sometimes you just try to correlate some external data signal to your basically time series, and you find nothing, actually 99% of the time. So also the availability is a problem because a lot of the high quality data sources are basically expensive or basically you need special subscriptions and so on to get them. There is a lot of need for interpretation. I can tell you, if you pull climate data, you very quickly realize that you're not really a data scientist. In that area, you're not really a climate scientist. You don't know how exactly to interpret the readings of all these stations in order to be able to understand what it takes, basically, for what it means for your customers. And the cost is there, basically. So, but what is also interesting, and is probably the most valuable learning from this area, is that if you actually, there is an uneven impact of the data on your solution. And if you take the various external data sources from the most impactful to the least impactful and order them, the chart looks pretty much like that, basically. There is 1 or 2 data sources which really make a lot of impact on the problem you're trying to solve. There are few with medium impact, and there's a great number with very low impact. So actually, if you deal with these two guys, in our case, basically it is the public holidays and the climate around public holidays, actually, not the climate in general. Then you have dealt with 70% of the issue, and then of course you can continue adding the rest of them, because every next percentage is more valuable than the last. But basically, you need to be aware of what works, and the best person to tell you what works are the people who have been working in the industry for 20 years, because they know it intuitively, more or less. Now, the next thing is big data versus small data. Now, if we are building a solution, let's say the green circle is the total value for the customer of our solution. Now, if you ask me what percentage of that total value is caused by this solution being big data driven, I would say at the most about 1/3, basically. A lot of the value can be extracted by just looking at the historical data, which is, I would say, okay, it's not small data, it's in the case of DHL 5 to 10 billion records, but it's, let's say, medium data. And it's actually the green part is easier to get than the gray part anyway. Why is that? At least for the cargo transport, the gain comes mainly for business process improvement, and the business processes are anyway rather inefficient today. And you can improve the profit by just using their internal data a lot of the time. So why bother with big data, actually? There are two reasons, or three reasons, actually. The first one is that the big data is a trigger for action. They want to do something, and it's much easier to sell a solution which has big data factors inside than just a solution which says, oh, we are going to do something with your internal data, which is basically they immediately say, why can't we do the same basically ourselves? Why do we need to pay someone to do it? And they can't, but that's another story. I'll come back to it. And the other value is, it's a bit more subtle, but basically a lot of these big data impacts are already considered by people who are doing the planning today. So they know that if there is a holiday, there will be something. If it rains during the holiday, there will be something, and so on. But it's in the heads of the people, and it's inconsistent. While a system is, first of all, systematic, and then it's inside the organization, not inside of the heads of the people. So there is value for the organization in standardizing these processes of consulting the external data. But really the most important factor is probably looking at the future, basically, because if you look at the impact without big data, you're going to get somewhere and then it's going to get kept out. But now the whole big data industry is just getting started, very similar to cloud, basically in 2007, 2008. And over the long term, basically the opportunities to improve by consulting the external data are going to be more and more and more. So it's in a way investment for the future, basically. Investing in a system which is not going to just achieve an impact and then stay there, but which is going to achieve an impact and then is going to continue improving and improving and improving as time goes and as the data becomes more sophisticated and more mature. Now, a few things about the technology. So our customers, they live in the 1990s, and their systems look a bit like that mostly. And that's the reality of it. Basically, they don't have they have some business intelligence or data warehouses which are mostly for operational needs, tracking profitability and tracking service levels. It's not designed basically to be looking or doing data mining on it. It doesn't work. You cannot. Even transferring the data, even in DHL is probably the most sophisticated IT company from among the transport companies, and it took them 3 months to transfer the data to us. For other customers, it takes sometimes 6 months, just to give us 3 years of historical data so we can see the algorithms. So in that aspect, in that context, we have to do the solution. And then the other thing it turned out is that the CIOs in the companies are hungry for big data solutions, but they cannot sell anything to the CEO, basically. They are completely non-factor in the management of cargo. So we have to talk to the CEOs. And the CEOs are interested in 2 things. First of all, does it increase revenue? And the second one, does it increase profit? And anything else really doesn't work, doesn't give them anything, so they don't buy it. And what does it mean for the technologies? We need to sell a solution to a business problem. the customer is buying for the solution to the business problem, which means that they would be willing to pay exactly the same amount for the solution plus the hardware plus the software behind it, as they would be willing to pay for just the software. Or in our minds, at least, we are paying for the IT infrastructure and IT tools that we are using out of our own pocket, because it doesn't make a difference in the amount of money that the customer pays to us for the solution. In that respect, basically, it was a very big struggle to find the right software. Now, the hardware part is fine. Basically, there is an abundance of amazingly good hardware solutions offered by IBM, offered by Microsoft, offered by a lot of large companies. We personally went with SoftLayer, and it was okay. Basically, now we're going to go in-house for a while. But generally, the hardware is completely fine. The software is a mess. In the software part, basically, we have three actually options. The first option is go for an open source or community edition software. And the issue there is performance. A lot of the community editions versions basically will run on a single core and basically are kept in a certain way because you don't want to be paying money. The support is not there, and or is difficult to get because it's an open source, whatever. And the security is always a concern, and I'm not claiming here that open source is not secure. It certainly is. The point is that since we are not the deep experts in exactly this type of open source and there is not enough support, it's difficult to assure yourself that you have achieved the right level of security when using open source, because you might have just deployed it incorrectly one way or another. The other option is the legacy big vendor, and there basically we immediately stumbled onto the cost, because actually it seems like the customers, basically the big vendors are looking to charge about the same amount for the basically software that we should be using that the customer is willing to pay for the total solution. And that's why probably no one in transport at the moment is buying any software to do with big data predictive analytics, because basically they have to pay all the money they want and they are not getting the solution that they want. So that really stops us from going in that category. And then in terms of at least some of the vendors, basically there is the issue of privacy. At least if you put your data in Google, Amazon, it's fine because it's your data, you can decide what to do with it. But if you put your customers' data in Google or Amazon, it's a completely different dimension. Then you need to convince your customer that their data is safe, and that's much more difficult. And then there's, with some vendors, the issue of lock-in. Basically, they give a lot for free and so on, but they want you to be specific to their platform, and then you are locked in. And then, of course, there are a great number of other startups developing in the area, and they are amazing products with very high potential, very high promise. And what is the issue there? First of all, the uncertain quality. It's a startup, and we are startups, so we know what a startup is like. So it's very difficult to trust other startups. And the other thing is the uncertain roadmap, basically. You don't know whether they're going to be there in 12 months or not. And then the third one, which really drives me nuts, is the risk squared. Basically, you are a startup, you have a risk. You're relying on another startup which also has a risk, which means you multiply the two risks. And something is going to fail. Either you are going to fail or they are going to fail. And after a lot of experimentation, basically we decided to go anyway for the open source and for one other startup. But I'm not saying that this is a decision which makes us comfortable. It's just what we could do at this stage. This other startup we're using, it's called MamutDB. It's another company in Bulgaria. I trust them because they're my co-founders from my first company, which got sold to VMware, so they're good people. It basically is a distributed OAuth system which runs on InfoBright and Hadoop and allows you to break your database into chunks while continuing to use SQL on top of it to analyze the data. And it runs on inexpensive PC servers, and it's very immature, so it's very difficult to work with it. But it handles 5 billion records okay, and otherwise we had problem even with 500 million if we wanted to do more complicated stuff on it. And finally, just to wrap it up, 3 tips for down the road, from what I've learned at least. The first thing is that it's you may be building a big data solution, but it's important to find the small data part, the part which relates to business improvement, and deal with it first and then improve it with big data. Because that's why you can capture much faster the larger part of the potential, and then also understand what your customer really needs. And the second thing is, today companies don't know how to make money with big data, so you have to show them or they won't buy. So it's not about offering them an interesting technology, you need to show them how this is going to make them money. And finally, it's very emerging stage technology at the moment. Everything is emerging, nothing is there. So the name of the game is probably survival more than growth. Basically, be on the market, learn, improve, and wait for the big kind of growth which is going to happen in a few years. All right, so thank you very much. In case you have any questions, I'm here. Yeah.
Do we have any other question? Okay, maybe I do have a question.
Yeah.
So you won this award by Cloud a few months ago.
Yeah.
Could you maybe explain to the audience what has been the impact of this award? Like, is this the money of the awards which was the most important? Is the coaching? What do you get out of this?
Well, the money actually, it was nice. It turned out to be completely not important because I thought that actually we would need the money in order to make it to the seed round. And the award was 30,000 euros. And actually, when we got the money in the seed round and we could use them, we had exactly 30,000 euros in the account. So basically, the money itself, I mean, we are still going to use it and it will be very valuable, but I would say it's the least important part of it. What is more important is that I had basically what happens with a lot of competitions, and we've been at Pioneers Top 8 and the basically European Venture Summit and so on. We always kind of score highly, but all of them basically you go there, you go on the stage, you get an award and so on, and then it's finished basically. You never hear from them again. And here, basically, it has been an ongoing relationship. So there's always opportunities to meet people, to talk, basically, there are coaching opportunities. It feels like you're part of a family. And it's a very good family, basically. It's probably for Europe the right type of family because we are not the US, we are not the Silicon Valley. Our edge is really more in the research-heavy, science-heavy solutions rather than basically the consumer space, and it's very good basically to have you guys here.
Any more questions? Yes.
So you said that your customer, your knowledge. Oh, hi. You said your knowledge of the sort of the area gave you the customers to go and talk to. Mm-hmm. What would you do if you didn't have that knowledge?
Well, then I would look for very good advisors to lead me in this area. But I think actually it's a very, you should think very, very hard before going into an area where you don't have an experience and trying to do a startup there, basically, because I don't see a way I could have made it actually if this wasn't there. Honestly, I think it's just close to impossible, at least if you want to go into a big industry.
Yes, can you elaborate a little bit on the process, because you start first with small data, as I understand, with ROI hints, maybe, mm-hmm. and then progressively, and that's the interesting part, you go to more big data techniques mm-hmm. and to ROI certainty. How do you, can you elaborate on that process, because it's what happens every day in the big data process?
So the way our software works is it produces a prediction of how much the empty space is going to be on a given day in a given vehicle. And what you do is basically you start the prediction by using just historical data. That's the small data part. And then you do the best you can there. And because obviously you are getting feedback on how well the algorithm performs, you see where the algorithm makes the biggest errors. So after you establish the baseline of how much you can improve with the small data, which gives you a lot of ROI already, then you can start looking at the biggest errors and try to correlate them to a big data source. In our case, we saw that the largest concentrations of errors happened around the public holidays. So this gives you already the indication of the first external data source you should use. Basically, every possible public holiday in every municipality in the world, basically, in order to improve. And then once you get this, basically you get a new baseline which already has the holidays inside. And then you look again at where the biggest errors in the forecast are. And then you look at what is the next big information. In our case, for example, some of the big holidays didn't work as planned because the weather was so extreme around them. And then you start plugging the weather around these holidays. And then you look at the next level of errors, and they always get smaller. But if you actually, the value between having 90 and 91% is improvement is much smaller than between having 96 and 97 correctness. So basically, it still makes sense to continue fine-tuning.
All right, so thanks a lot.
Thank you very much.
We have a coffee break now.